Alright guys, so this is a review of a Pythagorean theorem. So we've already studied this and we've done the proof to show that a squared plus b squared equals c squared. So if you remember, if you were given a and b, which are the legs of the triangle, a and b are the legs, then you know that this you will add. Okay. If you were given a and c, meaning that you were given the hypotenuse, which we know is the longest side, then you will end up subtracting. Okay, subtracting. And again, if you're given C and B, again you're given the hypotenuse, so then you will need to subtract the squares and take the square root. So when we talk about word problems, one of the things to look for is keywords. So if you have a 10-foot ladder that's leaning, you need to know that they've given you a C side. 5 miles east, we know would go that way, so they've given you an A or a B. South, we know that goes straight that way, so again, they have given you A or B. 9-inch hypotenuse, that's like the key word there, so you've been given a C. A 4-foot slant, so they've given you C. A 20-foot house, that usually means the height of it, so then that would be A or B. 9 feet away from the base, so you're away from the bottom, that would go this way. So again, if this was your little house, you know, you're 9 feet away, so then this would be an A or a B. So a leg, right there is another key vocabulary word. A's and B's are the legs of your triangle, so they have given you an A or a B. 8 miles southeast, I mean the southeast goes at a slanted angle, so therefore they've given you a C side. Same thing with northwest, they've given you a C side. Length and width. Now, length and width we know goes this way. So essentially they've given you legs. And they say length and width of 10, so they've given you A and B. And then right here is another key word, diagonal. Diagonal we know goes this way, so they've given you a C side. So when we've talked about vocabulary here, just kind of knowing what to look for, draw yourself a picture. Even if it's as pitiful as my house down there, draw something to help you. So they're going to give you a triangle of some sort and ask you to find the missing side. So let's say that this is 6 and this is 12 and then this is x here. So we see that this is the missing side. Notice that it is the missing side that makes the 90 degrees, so it's one of your legs. So we know that if you have this, then a squared plus b squared equals c squared. Well, we know from previous work you're going to have to subtract. So b squared actually gets c squared minus a squared, and we know to take the square root of that to get b. So we could actually go ahead and just put in our calculator, if we know this much of it, we can just say, alright, well I know that c is 12, so the square root of 12 squared minus 6 squared, which is the square root of 144 minus 36. And so then 144 minus 36 is 108. And so the square root of 108, and if they allow you to give that in a decimal, that's fine, which for this review, that will be fine. We simplified square roots in the past. I'm not going to concentrate on this video on that. But so this would be 10.4. Now, if we talk about the reasonableness of our answer, we know that 12 is the longest side. So this does have to be shorter than 12. So 10.4 would be a sufficient measurement for that. Okay, so let's move on. I'll come to that, back to that. But let's just quickly, if I were to have this triangle here, and they would tell me that's 90 degrees and give me 6 and 8, then I would say, okay, that's the square root of 6 squared plus 8 squared. And so that I'm looking for the C side because it is opposite at 90-degree angles. And then you would follow the formula. Again, this is not necessarily focusing on the beginnings of the Pythagorean theorem because you already have that mastered. So let's just keep going on there. All right, so we have to remember that distance is actually the Pythagorean theorem. So if you're thinking about graphing a point, if you were to do 5, let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4. So 5, -4 would be here, and then 6, 7, 8, 5, 6, 7. So 8, negative 7 would be about down in here. So it's not letting me put a dot there. There we go. So you're actually finding a slanted side. So we know from our study of slope in a line that we can make a triangle there. And so if we do that, we're essentially finding the distance of this and the distance of this to look for the distance of the hypotenuse. So remember, if we use slope down and over, we could get our A and B. So we're going to do the same thing here. I'm going to say how far, I can either ask myself how far it is from negative 7 to negative 4, which would be that I would add 3, okay? Or we could say negative 7 minus negative 4, and we would get negative 3. And then we could say how far is it from 8 to 5, and that's down 3, or we could say 8 minus 5, which is 3. Now, before, when we've done the slope, we've reduced that. We don't want to do that. We see that there is a smaller triangle around in there, but we don't want to. We want to use these as our A and B's. Because it says distance, I'm not concerned about the negative 3. That's the direction. I'm worried about the magnitude of how far it is between those 2 points. So I can use 3 as my A and 3 as my B. So 3 squared plus 3 squared, and then take that square root, will get me that missing side. And you can call it C here if you want to. So then this would be the square root of 18, because we know that 3 squared is 9, and 9 plus 9 is 18. So then I can take the square root of, I can simplify the square root of 18 into 3 on the square root of 2, which again is not the focus of this video, but you could do that, and then, or you could just say the square root of 18 and get your answer there, if I could put it in there. And so then that would be 4.2. Again, because we're always looking for the C side when it says distance, we always want that number to be bigger than either one of these two numbers. So let's do the same thing. We know that the distance from 5 to 6 is 1, up 1, so I'm going to let that be my A. So from 5 to 6 is 1, so I'll say A is 1. And then from negative 7 to 12. Now that's quite a bit, because you're going from negative 7 to positive 12. So you're actually going to 19. If you say 12 minus negative 7, that means you would add 7, so it's 19. So B there is 19. So 12 minus negative 7, we would get that that's 19 units apart. So here I have the square root of 1 squared plus 19 squared, and we know that 1 squared is 1, so then 19 squared is 361 plus 1 is 362, so this would be the square root of 362. And so then I could simplify that again and leave it in its most exact form, but for right now, the decimal is sufficient. So 362, and then take the square root there, and I get that that is 19.02. Now, look how close that is together. Part of that is because this number here is so small, and this one is so large, that you're going to get fairly close together, but this number will always be a little bit bigger. So I hope that helps you to find distance. Now, the other way we can use the Pythagorean theorem is if we're trying to find perimeters in triangles. Now, we understand that the Pythagorean theorem only works in right triangles. So if I'm going to use the Pythagorean theorem, I have to be able to make a right triangle. So here, we can see that if I use the altitude to cut this, to bisect this line here, I actually make 2 right triangles. And so to find the perimeter, I need all of these pieces. And I guess I should just use different letters there. So, we know that this is, if it's marked, which it should be, it's an isosceles triangle, so these will actually be the same, but this one may not be. So I already know that because this bisects this, that this is also 25, so that one's fairly easy. But I need to know this line, and we know that this is the hypotenuse. So I could use the Pythagorean theorem. I know that this is my C side because it's opposite to say 25 squared plus 10 squared. So then we know that 10 squared is 100. You may not know what 25 squared is, but it's 625. And I wrote the wrong thing there. So this would be 100, and this is 625. So this would be the square root of 725. Again, if they're asking you to find the perimeter, usually the decimal is the same, or is sufficient unless otherwise stated. For us, it will be when you get in high school. Maybe there's something else in there for that. So this is going to be 26.9. So we know that this is same. It's going to be 26.9. And so then if I'm asked to find the perimeter, I'm going to add all these values together. So 26.9 times 2, because I have 2 of those. And then I have 50 from the bottom. And so that's going to get me a perimeter of 103.8. Remember that perimeter is a distance around, and so you would add all those units together. And I'm going to make sure I say inches to make that more exact there, and more correct. All right, so then lastly we have a shape like this. So this would be 1, 2, 3, 4, 5, 6, 7, an 8-sided figure. I'm not going to mark that one. Again, I need this part, and I can only use a right triangle. So you can see that I have the hypotenuse and the altitude there. So I want to say 15 squared minus 10 squared because I have the hypotenuse. And so if I say 15 squared minus 10 squared, which is 100, then I get the square root of 125. So the square root of 125. So when I say the square root of 125, then I get 11.2. So I have to ask myself, what is 11.2? Well, because I only used half of this is only 11.2. So that means this is 11.2 also. So that would be 22.4. So each side is 22.4. Now, we already counted that this is 8 sides. So then I would just say 22.4 times 8. And then I would get my answer. And so this would be 179.2. And if it had units on it, which it does, I would say inches. So I hope that helps. Remember to make your right triangle, figure out how much of it you need, and then use it.